Yeah, this is probably a good way to end. Rationalizing the denominator. Let's see how much you can think about this. See, there's a little bit of logic involved in this here mathematical stuff that we have here. If the title of this is rationalizing the denominator, what do you suppose is our problem? If we are rationalizing the denominator, what is the problem, Evelyn?
Our denominator is irrational.
Exactly. See how Evelyn picked that up? What's it mean? What are irrational numbers?
Numbers that are irrational.
Now we got a couple, and let's skip pi.
Square root of 2.
Wait.
Square roots don't work.
Right, square roots are better. Wait, did your voice change? Don't worry, wait. In other words, here's the deal, ladies and gentlemen. If you have this, 1 over the square root of 3, okay, you have an irrational number in the denominator, and for some reason in the mathematical world, they say that that is unacceptable. You may not keep an irrational number in the denominator. Now notice it doesn't say the numerator. Irrational numbers in the numerator are fine. In the denominator, it's a bad thing. Okay, that is the gist of this. You can't keep this as 1 over the square root of 3. Okay? So the question is, we need to fix that. How to fix? Can anybody think of what you could do to that to make it so that the denominator is no longer irrational? Again, the top can be irrational, but the bottom can't. You think about stuff we do with fractions, Faith.
Or you can multiply both the top and bottom by the square root of 3.
And that's it. That is absolutely it. Whatever the bottom is, you multiply both the top and the bottom by it. Why? Because when you multiply by the same thing over the same thing, it's like multiplying by 1, and you're not really changing the fraction, you're just changing the form of it. It's going to mean the same thing. What happens when you do that? Well, the square root of 3 times the square root of 3 gives you the square root of 9, but the square root of 9 is a perfect square, which is just 3. Anytime you have the two same square roots times themselves, you get the normal number. And then on top, you get 1 times the square root of 3, which is the square root of 3. This, boys and girls and children of all ages, is acceptable, relatively. Now, hopefully, you should be able to give some sort of an estimate as to what that would be. Which maybe that's why we do it, because this one gets a little goofy. You know, the square root of 3 is what? What did we do it over there? 1 point something. What was it? We should know what it is. It's written somewhere. Too many places it's written that we should know what it is.
1.28.
The square root of 3 is 1.73. Okay. So if you had 1.73 over 3, you know, you're getting close to what? A third. It's not 1, it's whatever it is, but you know, you get something close to it. But I say 1.7 over 3, which would be 17 over 30. It's close to a half, I suppose. Now, if it doesn't get much more difficult than that, let me give you just a couple here from the book. What do you get if you have 4 over the square root of 2? Again, this would be simplifying this or rationalizing the denominator. You'd have to multiply both top and bottom by this time the square root of 2 over the square root of 2. Look at this one, works out a little nicer because you end up with a normal 2 over 4 times the square root of 2. But that can be simplified, yes, can it not?
Divide.
Yeah. 2 goes into 4 2 times, so this actually equals 2 times the square root of 2. And you can do this as long as this is multiplication. I could not have done that had it been plus. 4 plus the square root of 2 over 2, you could not simplify that. But since it's multiplication, you can. What else? There's got to be more. Oh yeah, how about this one? The toughest one of all. How about 2 times the square root of 3 over the square root of 2? I'll give you a chance to rationalize that denominator there. Rationalize that denominator there. Do we have an answer? Is it a fun answer? Abram is jumping out on a limb and saying,
5 over 2.
oh boy. 5 over 2?
I know.
Grant?
1 times the square root of 6.
1 times the square root of 6. You don't really, what is 1 times the square root of 6? You don't really need to say the 1 because the square root of 6. Yeah, that's exactly what it is. Look at Brant. So you multiply both top and bottom by the square root of 2. Square root of 2 times the square root of 2 gives you a normal 2. On top, you can multiply the 2 square roots together. You get the 2. 2 times 3 is the square root of 6. And then because you have 2 2's in its multiplication, you can cross those out and just be left with the square root of 6. How many people get at that? People did not get at that. How many people think they would get at it the next time? One more. How about 5 over the square root of 10? Let's rationalize. Thank you, Mrs. Leadham.
You're welcome. Rationalize is when you try to come up with the reason why you did something.
Logical, sir.
Yeah,
But you're
supposed
still
to,
rational.
especially when you're a teenager.
Yeah, there is no rationalization in the teenage world. I'll take it. And the survey, this one should not be too terribly difficult, would be, Carolyn, did you get something?
The square root is 10 over 2.
Square root of 10 over 2, did you say? No, let's see. Square root of 10, square root of 10, this crosses off to give you a normal 10, on top you get 5 times the square root of 10, 5 goes to 10 twice, yep. Square root of 10 over 2, which would be close to what? What is the square root of 10, something like 3? I don't know. We go about 1.5 or something like that.
3.3333333.
Did I do something wrong? Let's see what the calculator says. 10 square rooted divided by 2. Hold on, 1.5, 1.6 actually is what it's closer to. But notice how those digits keep right on the roll in there. All right, ladies and gents, welcome to the